Alright, so in this video you're going to learn how to solve simple exponential equations using common bases. And so we're still in our unit of exponential functions, and not going to lie, this is kind of tricky, but I'll get you through it, I promise. So on the front of your notes you have this table that's going to be useful to us, and so what I want you to do is to type these numbers into your calculator, or if, for example, you know what 3 squared is, 3 times 3, you can go ahead and put that number down there. But you may need your calculator for these negative numbers. So I want you to make sure to write fractions instead of decimals. So I'm going to teach you guys how to do one really quick. So if you take out your calculator, let's start down here with 4 squared, for example. So I would type 4, and if you need an exponent button, it's over here. So 4, raise it to the power of 2, and I would get 16. So in that box, I would write the number 16. Okay? So let's try one of these negative numbers instead. So if I want to do this -2 number, I can go up and hit enter twice, or go up twice and hit enter. And I can go edit this number, and I can insert with this blue button, so second, delete, and I can insert a negative in front of that 2 if I want. Or you could just type it all in over again. Okay, but remember, I don't want decimals. We need some fractions to kind of see what's happening. So to make a fraction, you're going to hit math and enter, because frac stands for fraction. And so that decimal is the same as 1/16. Okay, so what I want you to do is to try all of these problems, fill out this table, and then when you're done, I'm going to pop up the answers. So press pause right now, and then I'll throw up the answers. Alright, so here's what I got. Hopefully you guys were looking for some patterns that you noticed. But for example, this whole left side column was being multiplied by 2 going down. And if you look at it going upwards, it would be dividing by 2 or timesing by 1/2. This second column was being multiplied by a 3 because I've got this base of a 3x, or base over here. Same thing with the 4's going down, I was multiplying by 4, etc. Let's see, if you notice you had a 1's in this whole entire row, and that's because anything raised to the 0 power is going to be a 1. Maybe you notice that all these numbers were the exact base, so if you have a base raised to a 1, it will always be that base. And then hopefully you kind of saw this was a 64 in the denominator, and up here it was kind of in the numerator. So the relationship between 5 to the -2 power and 5 to the +2 power is when it's a positive number, you're going to have it in the numerator, so you're probably not going to have a fraction. If you've got the 5 to the -2, you're going to have that 25 in the denominator. Okay, so remember we kind of learned in the last class that if the 1 is negative, it's going to bring it down to the bottom, like this 1/5. So what this 5 to the -2 power means, it says, hey, take 5 squared down to the denominator, and then that's how you get 25 at the bottom. Okay? So we're going to be using this table today to refer back to. Obviously there are numbers that aren't on here, like 6 to the -4, that you may have to guess and check later, but this will be a really nice, helpful table. Alright, so now it's time to actually learn how to solve an exponential equation. So when you're solving things, you're trying to get x by itself, or trying to see what the left side will equal to be the right side. So if I have 3 to the power of x, this 3 is called your base. Okay, so when step 1, where it says find the base, it is the one with the exponent. Okay, so if you see an exponent, that is probably going to be your base with the x. So when you see a problem, look for your variable, and then the number below it is going to be your base. So when we solve equations, we have to rewrite the other side with the same base. Okay, so for the example in this first problem, I have a base of a 4 on the left and I have a base of 4 on the right. So that means, hey, I can go ahead and solve. Now how you solve exponential equations is you set the exponents equal to each other. So how I kind of think about it, 4 equals 4, right? So I already know that, so I can kind of cancel out those 4's. So now what I do is set the exponents equal. So I would say 3 minus 3k equals 2k. and then you just solve it like a normal equation. Okay, so I want to get my variables to one side and my coefficients to the other. So I notice I've got 2k's. If I subtract 2k, I'm going to have nothing left on this side, and my equation's going to be unbalanced. So I'm going to actually add 3k to get the variables on the same side. Drop down this 3 equals 5k. Now I divide by 5. And so you can either leave that as k equals 3/5, or if you want, you can change it to a decimal and say 0.6. Okay? So that would be my answer to this problem. All right? Now I'm going to show you a cool trick to find this in the graphing calculator. All right, so in our graphing calculator, what we're going to do is press y equals, and the first step is to type this whole left side into y1 and type the right side into y2, or vice versa. You just need one side and one of them. So I'm going to start with a 4, and I'm going to raise it into the power of a 3, subtract 3. Now it wants me to input a k as a variable, but our calculator only knows the word, or the variable x, so I'm going to put x. Then I'm going to go down and type 4, raise it to the power of 2k, but I just needed 2x. Okay? So if I type both of these in and I hit graph, we're going to look at two curves and kind of where they intersect. All right, so where the two graphs meet, that's going to be our solution. Okay, so I'm looking for the intersection. So remember when we did absolute value and I went to second trace, I'm going to do the same thing. So everyone hit second trace, and I'm looking for the intersection, so you can either scroll down or you can press the number 5. And then you just hit enter, enter, enter. And then it'll give me my number right here. The intersection was when x was a 0.6, which is what I found over here earlier. Okay? So your calculator, you can always check your answer, which is very cool. So I'm going to write those steps down for you. So in the calculator, press second, trace, 5, or the intersection, and then enter 3 times. Okay? So that is a cool way to always check your answer on a quiz, on your homework, if you have a calculator at home. Amazing. Okay? So how this is going to work is I just did a problem, and now I want you to try the right side. Okay? So try this one, check your answer in the calculator to get some extra practice on it, and then press pause and I'll throw up the answers. For the UG problem, you've got your same bases of a 3, so I can go ahead and cancel them out. And then so when you solve, you got to set your exponents equal to your exponent. So in this problem, you would have k plus 5 equals 2. Subtract 5 on both sides, and you would get a -3. Now, if you graphed it in the calculator, remember you're going to go to y equals. You're going to type the left side in the first one, the right side in the second one, and you hit graph, and this time you're not going to have two curves, you're just going to have a curve and a line. And so again, we're looking for the intersection, so I'm going to hit second trace. I'm going to press 5, and then enter, enter, enter. And so that worked out. I did get x as a 3, which is the same, or -3, which is the same as the -3 I got. So woo! Okay? Alright, let me know if you have any questions, typing in the calculator, solving it, etc. Otherwise, I'm going to move on to this one down here. So notice this is a little different. I don't have the same bases, and so what I'm going to have to do is first identify my base. And so my base is going to be a 3 because I had an exponent. So then I have to write my other side in the same base. So I'm going to drop down the 3 to the x, and I'm going to put a 3 with a question mark because I don't know what my exponent is yet. I just know that it has to be a base 3 on the right side. So what you're going to have to do is either guess and check. 3 to the what power is going to get you an 81. Maybe you already know it, but I'm going to show you how to guess and check. So let's try 3 to the second power. So 3 squared would give me a 9, so not quite there. Let's try 3 to the third power. 27, not quite there. So again, if you want to go up and hit enter, it'll kind of copy and paste it for you if that's faster. 3 to the fourth power is going to get me an 81, okay? So the reason I was guessing positive numbers in my exponent is because this is not a fraction. So I know my exponent should have been positive. So what I'm going to do is replace that question mark with a 4. and I know 3 to the 4 is the same as an 81. Okay, so now my bases are the same, so I can set my exponents equal. So I'm going to cancel out my 3 bases and say x equals 4, and I didn't have to do any extra steps because I'm completely done. Okay? Alright, I'm going to show you one more time how to graph this in the calculator, and then I promise I won't do it again. So, y equals, let me clear out my stuff from the last problem. So I'm going to type 3 to the x in the first one. Scroll down, type 81 in the second one. I'm going to hit graph. Now, 81 is going to be way off this screen because the screen only goes from a positive 10 to a negative 10. But fun fact, you don't even have to zoom out. So hit second, trace, 5, enter, 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 and it will still give you the answer even though you can't see the line 81. Okay? So x equals 4, I'm good. Alright, so why don't you try this right one? Check your answer in the calculator as well as doing it by hand. Press pause. For the next one, you should have gotten -1. So you noticed your bases weren't the same, and so I know my base was a 4 because that was the exponent, so I had to write the right term as a base 4. So I kind of guessed and checked. 4 to the 2 power didn't work, 4 to the 3 power actually worked. Okay? So again, I didn't check any negative numbers because the 64 was a positive number, bigger than 1, you knew it wasn't a fraction. So my bases were the same, so I can go ahead and set my exponents equal to each other, -3x equals 3, and you should have got -1. Okay, so I'm not going to show you how to type all these in the calculator again. If you are confused, raise your hand, let me know, and I'll come teach you. Otherwise, I assume that you are checking it in the calculator as we go. Alright, next one. We got a 1, and we learned in the first part that anything raised to a 0 power is a 1. So it's kind of like a little special case. So my base is at 2, so I'm going to drop down 2 to the 4x, and I know my right side has to be a base 2. And like I said earlier, anything raised to the 0 power is a 1, and so I can go ahead and put 0. That's the same thing as a 1. So now my bases are the same. I can cancel them out, leaving me with 4x equals 0, divide by 4, and I get x equals 0. Okay? So every single time, your x may not be 0, but your exponent is 0. So don't just think that, oh, x equals 0 is my answer all the time, because you'll see it's not the case, then you try. So why don't you go ahead and press pause, try the one on the right. Alright, for the you try, you should have gotten a 1. So again, 5 to the 0 power would get you that 1, since your bases had to be a 5. So then you set your left exponent equal to your right exponent, and see, I didn't get 0 every single time. Okay, you will just get 0 in the exponent. Alright, how we feeling? Ready to get some harder problems going? Woo! Alright, time to bring in the hard part, which is fractions. So fractions are tricky just because everyone hates fractions, right? I don't. I love them. So if I have a fraction, back to the front page, I know I have to have some negative exponent. Okay? So look right there. There's 1 over 64 for me. I know it's 4 to the -3 power. So what I'm going to do is my base is a 4. So I'm going to bring down the left side. And I know my base has to be a 4 on the right side. Okay? Then you have to ask yourself, 4 to the what is going to get you a -1 or a 1 over 64. And so if it's a fraction, you know you're going to have an exponent. And so you can ask yourself, well, I know 4 to the 3rd power is 64, so 4 to the -3 power is 1 over that. Okay? So if you need some help guessing and checking that, please let me know. And so my 4's will cancel out, leaving me with 8 minus x equals -3. I solved that by subtracting 8, because that 8 is positive out front. So I would get -x equals -11. Same thing as a -1 right there, imaginary -1. So I'm going to divide by -1, and I will get a positive 11. Okay? Alright, so I want you to try this fraction one over here, and then I only want you to try these two in the calculator. Do not show me any work for these two. I want you to just graph it in the calculator and find your answer. Okay? So don't show any work, alright? Only time I'll ever say that. Press pause. So for the you do, you had a 1 over 125, and so you knew you had to have a negative exponent, and if it was a base 5, you kind of guess and check, so 5 to the negative 1 didn't work, 5 to the negative 2 didn't work, 5 to the negative 3 gives you 1 over 125. So cross out your bases, go by 5s, setting your exponents equal to each other, and you should have gotten a positive 3. Okay? Let me know if you have any questions with the fractions. They do get tricky. And then if you did these two in the calculator, you should have got x equals 1 and p equals 2. Okay? So I'm not going to show you that for time's sake, but if you did not get those and you want me to help you type this in the calculator, please, 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 please let me know. Okay? All right, down to the insane problems, okay? So these are different because the exponent is in the denominator. Okay, usually it was just this number on the right, didn't have any letters, but now we have letters. So there are two ways to do these problems, and I will teach you both. So you can either bring this denominator up to the top, and I'll kind of show you that with a number, for example. If I had 1 over 4 squared, and I wanted to bring that 4 squared to the numerator, the exponent would change signs. Okay, and so we kind of know that earlier because 4 to the negative 2 power is a 16, and so 1 over 16 is the same as 4 to the negative 2. Okay, so if you take something from the denominator and you bring it to the numerator, its exponents change sign. We can also see that in 1/3, for example. If I want to bring that 3 up, that exponent becomes a negative 1. Okay, so you can do it that way. So I can bring this 1/3 and make it a 3, bring it to the numerator. Now if I do that, my exponents have to change signs. And so what you would do is put a negative out front and say, hey, I have to change all my exponent signs. Make sure you do parentheses because both numbers have to be affected. Okay? So that's one way of doing it. You can bring that exponent to the numerator, put a negative out front. So then I know my right side has to be a base 3. So I'm going to guess and check some numbers. So 3 to the 3rd power gives me 27, doesn't work. 3 to the 4th power doesn't work. It ends up being 3 to the 5th power. Will get you 243. Okay, now that your bases are the same, I can cancel them out, leaving you with a negative parentheses x plus 5 equals a 5. Okay, now you can either distribute, because this is a negative 1 out front, so if you want, you can distribute and get negative 1x, and then a negative 5 equals 5. Now I'll show you another way if this is better for you. To make it a shorter problem, you can also divide by a negative 1 off the bat. Those will cancel out, leaving you with x plus 5 equals negative 5. But regardless, if you say solve both of these problems, you're going to get a negative 10. Okay? So that is really tricky. So again, if you have an exponent in the denominator, you can bring this 3 up to the top, but it's going to change the signs of your exponents. Okay? That is one way. I'm about to erase this, so if you don't have it written down, press pause. The other way, which I think is a little bit easier, is you can keep this exponent in the denominator, and you can change the 243 to match the 1 over 3. So you can say, hey, I know my 3 has to be in the denominator, okay? But if I want to do that, I have to change the denominator sign. So I know this number is 3 to the 5 already, okay? We figured that out last time. So if I want to take that 243 and bring it to the bottom, that's going to be 3 to the negative 5. And I can double check it to see if it works. So in my calculator, I'm going to go ahead and go to the fraction button. So alpha y equals enter. I'm going to type 1 over 3 to the negative 5. Didn't put negative. Okay. Okay, and there's my answer. I know it's 243. Okay, so I know these numbers are now the same. All right. So once you have done that, then you have the same bases of a 1/3. And so these kind of go away, leaving you with x plus 5 equals negative 5, which is a whole lot less algebra. X equals negative 10. Okay? So these problems are tricky. If you like the way that I did it, where you keep it, you bring this number to the denominator, ask yourself, well, this is base 3 to the what power? 3 to the 5 power. Now when I bring it to the denominator, I have to change its sign. So the big thing is anytime you take something from the denominator to the numerator, you switch its exponent. When you take it from the numerator to the denominator, you switch the exponent. Okay? All right, so on your paper, I think I wrote 10 to the 3rd power, but go ahead and erase that and make it say 1,000 and see if you can solve this bad boy. I did this problem both ways to show you guys. So I did it the way that I like, which is less work. And so I brought this, first off I figured 1,000 was 10 to the 3rd power. And then I wanted to bring this 10 to the 3rd power to match its base over here in the denominator. Now when I bring 10 to the 3rd power down, it's going to become a negative 3. So then I had my same base of 1 over 10, and then I could say x plus 3 equaled negative 3 and solve to get negative 6. That's one way. The other way, you could have brought this 10 to the x plus 3 up to the numerator and changing the exponents this way and say, hey, there's a negative out front, I need to change all my exponents. And I knew this 1,000 was 10 base 3, or base 10 raised to the 3. All right, so then I could set my exponents equal, which is a little bit more math, so a little bit more ways to get confused or mess up or make a mistake. So distribute your negative to get negative x minus 3, add 3 to both sides, and then divide by that negative 1 to get a negative 6. Okay? So both ways are perfectly fine. This way is a little bit more work, but pick whichever way works for you. Okay? So if you have any questions on any of this, please let me know. Sorry this video is so long, but this stuff is insane. But you guys can do it, and I'll help you through it. So thanks for watching. Now you can practice.